Now, whenever you're doing any sort of scientific experimentation, you're probably observing a handful of different things. You're maybe observing the mass of a substance. You're maybe looking at the time that a process takes, the distance that something travels, the distance, electric current or the electric current being conducted. Not an electrical engineer, so I might be using the terminology wrong. The temperature of a substance or the temperature of a process, number of particles, and last but not least, the light intensity of a substance or the light intensity of a reaction. Now, whenever you're studying any one of these properties or asking any question related to any of these things, it's always important to kind of be speaking the same language as other people discussing these things. So we have specific units or SI units, international or system international units for measuring all these different substances. The SI unit for mass is kilograms or kg, time is seconds, SEC or S. Distance is going to be meters. Electric current is amperes or amps. The temperature is measured in a unit known as Kelvin. The number of particles are moles. And finally, the light intensity is candela or CD. Now, some of these, if you've taken a chemistry class before, they might be a little bit familiar to you, specifically temperature being measured in Kelvin. One thing that's important is when you report the temperature in Kelvin, if you say it's 412, you wouldn't say 412 degrees Kelvin. Instead, the convention is to say 412 Kelvin. So that's your units for temperature. In addition to Kelvin being the unit, this is also unique because it's an absolute scale. So there is no zero, or the absolute zero is unattainable. So what that means is there's no negative Kelvin, negative 50 Kelvin or anything like that. Zero is the lowest that the temperature can be measured in Kelvin. All right, well, I hope this is helpful. Quick review of your SI units.